All right, I just did week 3. Now we're going to do week 4 of Math 5, quizzes 3 and 4, and getting ready for multiplying and dividing fractions. Ooh, what an important skill. And quiz 1 and 2, in getting ready for powers of 10, aka exponents. Okay, so we're going to put those here. What are we doing? Quizzes 3 and 4. Okay, start the quiz. Quiz 3. What is the area of this rectangle? Right, the area of a rectangle, A, for area of a rectangle, is defined to be base times height. Where the base and the height of a rectangle, they're the two sides connected by any corner. So 4 and 11. The area of the rectangle is 44. Not bad. All right, now what's going on here? The following rectangle is partially split into unit squares. What is the area of the rectangle above? Okay, all right, I see. We want to figure this out here. So, all right, so it looks like we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So the height is 9, and then 1, 2, 3. I can gather that we have 3 across. So 3 times 9, what's 3 times 9? 27. Okay. The rug has an, so this one, we have the area, all right, on the inside is 36. So what is the length? So with this one, we're going backwards, right? We have the height or the width, same thing, and we don't have the length. So whenever we're missing a dimension, we have to divide. We have to write this, 4 divided by 36. And what is that? That's a whole number. That would be 9. So the length or the base would be 9. Okay. So count the squares and then figure out which one has the same. I don't want to spoil the fun for you. What is the area? I don't want to spoil the fun for you. That one has a little trick, but let's see if we can figure it out. Okay, now we're going to do quiz 4. Is that right? Let's do it. Collect those mastery points. All right. What is 1 7/10 times 5? Whenever I do this, change my mixed numbers into improper fractions. So I'm going to do 1 times the denominator plus the numerator. So 1 times 10 plus 7 all over the denominator. And it's being multiplied by that 5. But now that I better make it a fraction. So I'll do 5 over 1. All right. So here we go. So 1 times 10 is 10 plus 7 is 17. So now our problem becomes 17/10 times 5 over 1. So what is 17 times 5? I can do that in my head. 5 times 10 is 50. 5 times 7 is 35. So that's 85. Yeah, add those together. And 10 times 1 is 10. Oh man. Now they put them back in mixed numbers. But that's okay. That's okay. We know it's not 75 over 10. And we could reduce it. But I don't think to 2. Oh, maybe we could reduce it to 2 because we could think of it as 80 over 10 and 5 over 10, right? That would be 8 and 1/2. 5 over 10 is 1/2, right? So that one works. But then the other one, 17 over 2, let's take and do 8 times 2 is 16 plus 1 is 17. Oh, look at that. That was a tricky one. I'm glad we did that one together. So let's review. I had to change my mixed number to an improper fraction. Then I multiplied across the top. Then the part where someone must have got lost is right here. What did I do? I separated 85 into 80 and 5. Why did I do that? Because 80 can be divided by 10. That's the biggest number in 85 that can evenly be divided by 10. You know, what can be divided by 10? 20, 30, 40, 50, 60, 70, 80. So when I did that, I got my whole number. And then 5/10 was just a fraction left over, and it reduced. As you can see, I was also correct. How can we calculate the shaded area? For all that thinking, I don't know. Let's see. So we have 3 across and 4 down. And so, okay, so how many total do we have? 1, 2, 3. We have 12 total, and there's 1, 2, 3, 4, 5, 6, 7, 8 out of 12. And so was this 8 times 1/3? Are these 1/3? I think, oh, yes, these are 1/3 if you look across. And how many of them are there? There are 8. So that's one way to do it. But then, yeah, the C is the way that I'm thinking about it. I'm seeing 4 rows, and each row has 3, but 2 are shaded in. So that would be 2 out of 3, or 2/3. You see, if you look across, you see the 2/3 shaded in each one, and there's 4 rows. So there you go. And so now you know 8 times 1/3 is the same as 4 times 2/3. Okay, we're building our number sense. Okay, 3/2 times 5. Well, you can do that one. Put that 5 over 1 and go for it. All right, make it into an improper fraction and go for it. Move the dot. We haven't done that. All right, move the dot to the number that equals 2 times 4/3. You can do it. Put the 2 over 1 and give it a try. Okay. So there we go. Now let's do the powers of 10. Quiz 1 and 2, right? Quiz 1 and 2 and powers of 10. Don't worry, you guys are doing really good. Okay, fill in the blank. So we're gonna do an inequality, right? Oh no. So how much more is it? If there's 1 0, it's 10 times as much. 10 times, 10 more than, no, 10 times as much. 50 divided by 10 is 5. Okay, you should know that. And then 50 times 10 is going to be 5 with 2 zeros. So when we divide by 10, we take away a 0. And when we multiply by 10, we add a 0. 18 thousandths times 10 would be 18 thousands with an extra 0, right? So 18 with a 0 would be 180. So 1800 thousandths. There you go. But it's actually 18 10,000ths because we're adding 1 extra 0. But it would be 1800,000, not 1800 thousands. Very tricky. Put it in the organizer if you want me to explain it again. Select the true or false for each equation. Okay, so 670 times 10 is going to be 670 with an extra 0. True. 70 times 10, true. 6,000 divided by 10 is going to be 60. False. It would be 600, right? Take away 1 0. Okay. What will be the place value? Well, it would be in the ones now, wouldn't it? So it's a good one. It's very important to know your powers of 10 and be able to use those. It should not be a mystery. They should be nice and easy, but they really help you. Okay. Each big square below represents one whole. express the shaded area as both a fraction and a decimal. And so we have 1, and then there's 100 little tiny squares, and 99 over 100. Proper fraction or an improper fraction? A mixed number. Okay. And the decimal would be 1.99. A good one. Now we're getting into decimals. So decimals, yeah, you want to think of those big blocks with all the little unit squares. All right, express the location of the point on the number line as shown as both a fraction and a decimal. This is in between 2/10 and 3/10. It's right in the middle of it too. So would that be 2.5 tenths? But we don't say that. All right, so what we can say is, so if we know this is 0.2 and this is 0.3, this would be 0.25, which I think is a nicer way to think of it. And that would be 25 hundredths. All right, but I would like you to know that 25 hundredths is 1/4. We have a few memory decimals, and let's write them down right now. First one is 1/2. Everybody better know that's 0.5. The one we just did was 1/4 is 0.25. Please also know 3/4, 0.75. Why don't we know 1/3, 0.3333, repeating. And how about 2/3? We should know that, 0.66666, repeating. And, oh, okay. Well, let's just get all my memory decimals out of the way here. 1/5 is 0.2. 2/5 would be 0.4. 3/5, 0.6. Do you know 4/5 by now? 0.8. So I'm just thinking of the simple denominators, 2, 3, 4, 5. Yeah, but you should memorize those decimals. Okay, which of the following numbers are equivalent to 3 hundredths? 3 hundredths and 3 hundredths. That's 3/10. That's also 3/10. Express the point on the number line as both a fraction and a decimal. Well, you could do that. Last one, 2. All right, so there you go. Lots of good stuff for week 4. Okay, now I'm going to stop this video and do week 5.